In this video, I want to demonstrate how I would examine a part print for a part I need to create a CNC program for, and then determine how the part will be held and start planning the process. My first step would be to look at the overall part sizes, as shown here. It's just shy of 1.5 inches or 38 mil this way, and it's 50 mil or 1.969 inches this way, and it's 10 mil thick or 0.394 inches thick this way. And then up here I see my stock size is 1/2 inch by 1.5 inches by 2 1/8. So all sides will need to be machined to square up the block, and this is going to affect how I process and plan out my machining. For a part such as this, I might decide to put 2 of them in a vise, as shown here. I'll just zoom in on this. So I could put 2 parts in my vise. I could machine the top of this, do this radius, this side, and this radius in one setup, as well as these pockets and the drilling and tapping here. Then I could flip it over, and on this side of the vise I could machine this end to get the part's overall length, these radiuses, clean up this face and machine the pocket. I would then need another setup to machine this V into each side and get this dimension to the proper size. Now that I've made the decision that I'm going to hold my part in a vise to machine it, the next thing I need to do is consider tooling. Almost any size end mill will be able to machine this outside radius, this face, and this radius, as well as clean up the top surface. What I have to be careful of here is that I can still hold enough of the part in the vise, bring my end mill close to this jaw, come around this radius, this face, and this radius, and not touch my vise. I have the same consideration for the end mill to do the outside here, and then when it comes to the inside pocket, we'll go back to the part print and examine what determines our tool size there. For these 2 parts, I would very likely make this corner the 0 for this part, and this corner the 0 for this part. The reason being, they're both against the solid jaw, so as I replace the parts in and out of the vise, this never moves. And if I were doing multiple parts, I would have a permanent fixed hard stop here, again, that never moves. So I'm always pushing my part to the hard stops from the datum. And it would be easiest to program if the top of each part were the Z0. Thereby, anytime the tool is above the part, the Z value will be positive, and when it's engaged in a cut, the Z value will be negative. Now that I've determined my part zeros and how I'll hold the part for these 2 machining operations, in the next video we'll look at the actual process planning and what tooling could be used.